Hello, today we'll be proving the power rule for derivatives. So, the notation for this video, derivative of f of x is f apostrophe x. F of x means take the limit of h going to 0 of f of x plus h minus f of x divided by h. This just calculates the slope at x as h keeps on getting smaller. You can also write d over dx instead of f apostrophe x. We use this when we don't actually have a name for the function. We just write the numbers on the side. Okay, let's start. So we want to take the power of x to the power of a. Not take the power, take the derivative of x to the power of a. So we can write it like this. X plus h to the power of a minus x to the power of a divided by h. And now if you know how binomial expansion, we have to expand the whole function, the whole x plus h to the power of a like this. And then we minus x to the power of a at the very end, because that's what was here before. And we divide it all by h. So if you don't know what binomial expansion is, I will be making a video on that soon. But what it is just taking different combinations of numbers and combining them all together. So this is what this is saying is, when you add x plus h to the power of a, you get x to the power of a plus a choose 1, x to the power of a minus 1 plus h plus 1, and so on, all the way until you get to h to the power of a. Because as we continue, h keeps on growing and x keeps on shrinking, so at one point x to the power of a will equal 1, and we won't write it in. Okay. Next what we do is we cancel out the x to the power of a, because in this case they are redundant. Also, you cannot divide them by h, which means we can't actually do anything with them at that time. Now we should notice that all of them have h to the power of something, which means we can cancel out h on the bottom and h from each of these functions above. We can also just say that we are factoring out one h from this and then canceling out with this h. So what we get is limit h going to 0 of this. So we have what we had before, except now this one doesn't have any h, but all the rest do. And each of them have been minused by 1. That's why we end off with h to the power of a minus 1. Now we can evaluate the limit. What we can do is we can just substitute h equals 0, because now we're not actually going to have a division by 0 error. And that gives us everything, just substitute h, and now you notice that a lot of these are going to start being multiplied by 0, and 0 times something is always 0. You notice that there's still one function that is not affected by this, and that is the first function, the first one. So h choose 1 times x to the power of a minus 1. And now we can simplify this even further, because we know that n choose r equals n to the n factorial divided by r factorial times n minus r factorial. And when we plug this in, we get a choose 1 equals a, because r factorial is just going to equal 1. A factorial is equal to a times a minus 1 factorial, so we can cancel out the a minus 1 factorial, get a. So we fully simplify it to a times x to the power of a minus 1. Okay. Do a quick recap. We fully write out the function as a limit h going to 0 We expand the polynomial x plus h to the power of a. We expand it to this. We cancel out the x's, so we only have something times h. We now factor out h and cancel it from the numerator and denominator. We get this. We now notice that we can substitute h for 0, and we notice that everything except one function is going to be equal to 0, and that results in a times x to the power of a minus 1. Okay, I hope you enjoyed. Please send this to other people if they need help with power rule or if they have to prove it. Please subscribe so other people will be able to see this, and see you soon.